Today we're going to be talking about particle model of matter with a focus on pressure in gases. Now, we know that gases, the particles in a gas, are always in constant random motion. And so here we can see from the diagram where we have the gas particles, we can see that they're moving via this gray area here. Now, you can also see that as they move, they collide with the walls of the container and they bounce off. So as the particles are moving, they're exerting force on this specific area. And so pressure is force per unit area. So to calculate pressure, we have pressure is equal to force divided by area. Now, there's some factors that will affect the amount of pressure exerted by a gas. One of those would be the temperature, for example. So if we keep the volume constant, so we are not changing the space occupied, but we are increasing the temperature. Now, temperature has to do with the average kinetic energy of the particles. So that means the faster the particles are moving, more collision and therefore more pressure exerted on the walls of the container. And so as we increase the temperature, the pressure will increase. So pressure and temperature are directly proportional. That means as you increase the temperature, you increase the pressure. Now, another factor we need to consider is the volume. As we increase the volume, we can see that particles are more spread out, and so they will exert less force on the walls of the container. And so volume and pressure are what we say inversely proportional. That means that as the volume increases, the pressure will decrease.